In this video, I hope to show you how to use the bond dissociation energy table covered in section 6.82 of your book. Keeping in mind you have to be able to give me an estimate of any bond energy in a molecule, and keeping also in mind that I will not give any of these molecules on your test. This exercise is about finding the right category for your bond. I've reorganized the table a little bit so it's a little more lined up. Every one of these is in the category of a methyl group attached to whatever atom is being broken off. So here we're breaking off an H, here a fluorine, here a chlorine. And this is the amount of energy in kilojoules per mole to do that for 1 mole of bonds. So there's our methyl category along the top of the page. Next category along this row here, the carbon attached to the atom being broken off is a primary carbon. In the next row, the carbons are secondary. In the next row, they are all tertiary. Next row, we have a carbon. In each case here, a carbon that has an atom being broken off, and on the left we have a vinyl group attached. I want to remind you in chapter 5 we learned the name of this group here that starts off as a vinyl and has an extra carbon is called allele. So the category for everything in this row is allylic. The carbons themselves have only one other bond to carbon, so they're also primary. That is a category, primary allylic. Much easier to break an atom off of an allylic position than the same substitution number that's not allylic. Much easier when it's allylic. Read the textbook about the reason for that. It involves resonance. Next category down, each of the allylic carbons has another carbon attached, making them secondary. Next row, 3 carbons attached total, tertiary, all being allylic. And the next row, all the numbers are very high. You're breaking the atoms off of an sp2 hybridized carbon. This is the first time we've done that. Let's see the effect. It's quite big. Numbers going up by about 80 or 100. And that's the phenyl category. C6H5 is a phenyl group. Much like allylic and vinyl are related by the allyl having one more carbon, phenyl is also related to benzyl. Oop, I have to fix that. Benzylic is a position that has a carbon that's one away from a phenyl, attached to the phenyl, of course. It seems to be as special as allylic in terms of numbers. The numbers are low. Primary benzylic, secondary benzylic, and tertiary benzylic. And I have a new area over here. These are the highest numbers in each of in this row here. And that's vinyl. We've seen that before. No, we haven't. Vinyl would be H attached to the alkene directly. And that's similar to phenyl in terms of the numbers, and the phenyl is repeated here and here. And this one is the highest CH energy, which means you would never break that before any of the others. And it's an acetylene attached to an H, making that an acetylenyl group. Let's finish with an example that has several of these and see if we can find the right numbers. Here's my molecule. I am going to do every bond that's labeled hydrogens and halogens and come up with some numbers from the table above. Starting on the right side here, I have an iodine attached to a phenyl. Iodine attached to a phenyl is this number right here. The fluorine labeled here, it's on a secondary carbon, one away from a benzene. That is secondary benzylic. That's this number here. This carbon here, close to the phenyl, but not on the adjacent carbon, so that is just a garden variety secondary carbon, giving me a number of I was a little hasty on this previous one. I'll fix that in a second. This is a CH bond, so I'm way over here, and it's a secondary CH bond, secondary, which is this one right here. And I was in the whole wrong area looking up 197. I wanted a secondary benzylic carbon bonded to fluorine. Most of you probably spotted that. Carbon bonded to fluorine, secondary benzylic is this number here. Secondary benzylic, 420. And over here I'm going to do this carbon, which is tertiary, bonded to a chlorine. Just tertiary chlorine, that's this category here. Here is a carbon one away from a vinyl, which means this whole portion is called allele. So I need a secondary, because the carbon has 2 bonds to carbon, secondary allele. Secondary allele CH is over here, right there. Secondary allele. 357. I don't know why I did both of these. They're both vinyl, either from this number here or the same. Well, that's not. I thought it was in 2 places. It's not. 444 there, 444. Ooh, that is a big number. And 4440 there. And that leaves us with our. We didn't do this one, and we didn't do the CBr. Once again, that's a tertiary carbon because it has 3 bonds to C, and it's one away from a vinyl, which means that's tertiary allylic, C bonded to Br. C bonded to Br, tertiary allylic 224. And I never did my carbon here. The carbon with the H is secondary, and the secondary CH is 402. We already had one of those. And I hope this has been useful. And here's all the results. And hopefully this is going to help you with your tests.